And a very good day. Welcome back. So this is part 4 of the model your own antenna business. Last time we ended up with a plain vertical, which was ground mounted, and that's on the geometry tab. I don't know, I didn't save it, so I've redrawn it. This is currently at 14.275. It's 5.2 meters long, and it says W1B. Wire 1 fit the source, the coax, to the base. Okay, and that's the geometry tab, top left. The view tab shows us it here, with the red dot at the bottom being the coax. The calculate button, we're all ready to go, and I'll hit the start button. And this is a plain vertical, okay? And a far field shows us what it looks like over here. What I am going to do is I'm just going to save the far field plot as a vertical only ground. Just save the far field plot because we can compare it in a minute. Do some fun. All right, so what we need to do is let's assume this is for really low band. All right, so we will do some raised radials, just head height, 2 radials across the ground, and see what happens. This isn't an analytical video. You can go and add more radials and do what you want to do. I'm just showing you how to do it. So I'm going to hit the wire edit button, and we go to the XY. I'm going to slide that up and down. Hang on. There's the red dot. What we actually need is the X, is the YZ. So if you remember, what I'm trying to look at is this vertical sticking up here. I'm looking across Y and Z. And that's what we can see on the screen here, with Y going front and back. New wire. I'm going to go from there. I'm going to go about 5.2 meters. Well, that's 4.2. Let me change that to edit wire. 5.2. New wire. 5.2. And hit OK button. Now you can see that these 2 radials are actually on the ground. So we go to calculate. We can now lift it off the ground by 2 meters. Hit the start button. SWR might be a little bit out, but we will just quickly hit the plot. SWR resonance. 14,466. So the whole thing is a little bit too short. We could just increase the length very slightly, 5.25 of the main element. And you will now see that the SWR should creep down a little bit, and it has. Now I go to the far field plot. So this is just 2 only radials each side. We go to 10 meters, it says minus 1.9. Go to 5 meters off the ground, it says minus 5.6, which is almost identical to a ground mounted vertical, as it so happened. But I said I'd saved something, hadn't I? So we can do compare. So we can load the ground mounted vertical, open it up, and we get 2 different colors. So that's the ground mounted is in red, and the 2 elevated radials are in black. Okay, that's just important. And if you like, very quickly, we can add another couple of radials by going from XZ to YZ. Sorry, YZ to XZ. Able to put 2 identical 5.2 meter long, 5.5 that is. We will adjust that in a moment. Now it looks like this. But wires 4 and 5 are too long. 5.2 they want to be. Minus 5.2. They all need to be the same. That's fine. And if you like, we'll lift it off the ground a bit just to satisfy you. The SWR has hardly changed. Far field plot now looks like this. And we could do the tools compare function again. And so be it. It's not until reality you start sloping these radials down and going up high, which I will show you. All right, so we will go up to 8 meters high. So this will be on like a 12.4 meter pole, 7 meters high, right? SWR will change because we're now further off it, and we will adjust these radials. So now, instead of these radials going out parallel, we're going to bring them down to, say, there. This is how I do it. X, Z, Y, Z. And then we're going to bring these down as well. Okay. Now if we look at the view, we'll see it looks like this. And that feed point is at 7 meters off the ground. So I'm using a 12.4 meter pole effectively and raising the whole thing up. Right. We hit the start button and we will go to the far field plot. And it now starts to look like this. And at 5 degrees off the horizon, I happen to know we've gained 2 dB, but we could compare that anyway by loading the original ground-mounted vertical. You see there's not a lot in it, but it's starting to look a bit sort of 5/8-y. All right, so that's it for today. I've shown you the compare function. I've shown you the drawing function again, how to really think in 3D. We've done some elevated radials for a monobander, difficult to do with a multiband, tuned radials. Of course, the shorter the radials will be, the higher the frequency will be, because everything needs to be in balance. But let's not get into the technicalities. This job is to show you how to draw it yourself. Okay, so we've done elevated radials, we've done the ground mounted. I think the next one we'll do a couple of loops, and then we'll head into end-fed territory. Okay, so that's it for today. I will see you on the next one. All the best, and bye for now.